that things are starting to get hardwired in, and they're really learning that and getting very efficient at it, and at the same time, things that they're not working on as much begin to get pruned away. That's part of what's happening in the developmental brain, okay? So the two things that I want to say that the child is going through is, number one, slowly getting up here, but taking a long time to get to that prefrontal cortex, and number two, pruning and myelination. The stuff that they use gets more hardwired in, and stuff that they're not using begins to get pruned away. Make sense? So it's a very tender, crucial time. So I want to talk a little bit, just to give you some general drug education, so you begin to understand a little bit about drugs and why people take drugs. This is Drug Education 101. And it's interesting because, you know, mostly I work with high school kids, and I know when I was in Albany, parents would just, you know, why is my kid smoking marijuana? Why is my kid drinking alcohol? And you get the kids in a small group, and what they'll say is, duh, because it feels good. If it didn't feel good, they wouldn't do it. That's the same for adults. The reason why people take drugs and alcohol, at least initially, is because it feels good. So we need to understand what that process is. So we look in the brain, and inside the brain is an area in the brain here called the nucleus accumbens, or the reward center of the brain. Nucleus accumbens. And I don't know why I bother to write that up. You can't even see it back there. If I took a slice of the brain and looked at it under a microscope, if you remember your old high school biology, what I'm drawing is a brain cell. This is the cell membrane. This is the nucleus, and it has these long dendrites that reach out, okay? And I said this the other night, if there's a doctor out there, and there probably is, leave me alone, all right? Unless I say something that really drives you nuts. What I'm doing here, because I do a lot of reading on this stuff, and it is so complicated, it's hard for me. What I want to be able to do is kind of break it down a little bit and show a model, basically, of how things work. So it's simplified, but this is the model. Here's another brain cell. And what we want to begin to understand in how the brain works is, how do these two brain cells talk to one another? How do they communicate? And in order to understand that, we go to the end of the dendrite of one brain cell and the end of the dendrite of the other, and take this place here, and I want to blow it up. And it looks like this. So this is the end of one brain cell, this is the beginning of the next, and all the time we're getting input. There's things that are coming into our brain. We're eating, we're thinking, we're feeling, we're interacting. There's stuff that's going on. It's a stimulus. And when that stimulus happens in the brain, it fires off an electric spark. And the electric spark is called a synapse. And when the synapse happens, it fires information across to the next brain cell. Now, when we used to think about it many years ago, we would think that, well, the brain, it makes connections, you know, like the old-fashioned operator. Well, I really feel my age at this point. Some people have no idea what I'm talking about here. But there used to be these operators that would go, you have to watch Mad Men. They still got it there in that thing. Yeah. We used to think that the brain made connections, but really a better model for the brain is that the brain is a chemical factory. It makes chemicals, and those chemicals are called neurotransmitters. And so when this synapse happens, it fires chemicals across this space. And when that chemical hits its receptor site, the information gets passed. And then there's something called reuptake, and it comes back to the other side, so we don't lose our brain chemistry. We can keep firing it again and again, okay? In the nucleus accumbens of the brain, the chemical that fires off is a chemical called dopamine. Dopamina, see. Dopamine, okay? And this is an extremely powerful, motivating drug neurotransmitter that we have in our brain. When dopamine fires off, it gets our attention. We are interested. And it starts from the moment we come out of the womb and we get held. As soon as we're held, we know it's a good thing, and it releases dopamine, and it feels good. And what feels good is good. Next thing that happens is we get some nourishment, we get some mother's milk or whatever, it fires off dopamine, a good thing, okay? And this dopamine thing, we used to say was just a reward center, was pleasure. But it's way beyond pleasure. This is what gets our attention. This is the thing that gets our interest. If dopamine gets released, it gets our interest. And we all have different things that float our boat. An example of one that gets all of our interest is if somebody who you like touches your skin real nice. Okay? It touches your skin real nice. It feels good. If I looked at it biologically in someone's brain, what I would see is that the brain is firing off dopamine. So one way or another, it's giving us a message that says, I like that, I'm interested in that. And like to do it again. Right?
And again.
And again. Okay? It's a very powerful motivator. I mean, if you think about it, really, it's genetically the driving force in living beings. I mean, what's the highest dopamine release you can experience as a human being? Sex. Why? So we'll procreate the rest, so that we'll continue to do it. So this is a driving survival mechanism that goes on in the brain. And what we want from our kids as they're growing up is we want them to be able to have a whole bunch of things here that really get their attention and get their interest and get their life force. As a teacher, the thing that I wanted to do the most was light a spark with kids, so kids would get interested. So you've got something that's going on. That's what we're looking for. And that's what people are looking for from life in general, is what really gets our juices flowing here. What gets our interest. This is what we want to develop in our children. Now, what a child or an adult can discover is that I can bring something into the brain here that can trick the brain into doing the same thing. One of them, and I'm going to talk about it a little bit here, tetrahydrocannabinol, better known as marijuana. Another one is alcohol. And now we can go down the list, and I could scare you out of the room here, but it's, from crystal meth on down. Okay, but I don't care what the drug is, and everyone's brain now is different. You can have two people that drink alcohol, and one person drinks alcohol because they want to find out about it. By the way, the drug of choice in alcohol with teenagers is what's called a 40, which is a 40-ounce bottle of high alcoholic content beer. So instead of it being 3 to 4% alcohol, it's 7, 8, 9% alcohol, and a 40 is about 3.5 cans. And it is not unusual for a teenager to knock off 1 or 2 40s. Right?
Or 3 or 4.
Or 3. I want you to absorb this for a second. 3 or 4 40s. Let's see, 3.5, 7, 10.5, 11 cans. 14 cans of high alcoholic content beer. You really have to take that in. I'm going to talk about how teenagers can drink more than adults do. They don't even know that they're as drunk. But anyway, two girls want to find out about it. Could you imagine just drinking 3.5 cans of high alcohol content beer? I mean, I could feel a can of regular beer, no less that. Okay, so we have two kids that 7th grade, 8th grade, they want to find out about it. They drink alcohol. One girl gets sick, throws up, feels awful, has a hangover the next day, and says, alcohol, what a stupid drug. Who would want to do it? And there's a number of people in this room like that. Another person, I'm going to give you the two extremes. Another person drinks, the other girl drinks the alcohol, and for her, it is party time. She feels she can sing, she can dance, she doesn't care how people,